Okay, good afternoon, everyone. Thank you so much for joining us. For those of you who've been with us this afternoon, we've had a Grantham Institute research showcase all afternoon. You'll see some of the posters still out there. And we've been having conversations in small groups and larger groups all afternoon about the research that we're doing at Imperial around climate change. And we wanted to top that off with an engaging discussion with 3 interventions from people who are close to the Institute, and then the chance for you all in the audience to talk a little bit to us about what we can be doing now about helping progress action on climate change as quickly as possible. My name's Alyssa Gilbert. I'm the Director of Innovation at the Grantham Institute for Climate Change and the Environment, and the Director of Undaunted, which is our program on climate innovation. I'm going to be moderating this session to some extent. We're not going to make it necessarily moderate, though. We have 3 speakers who are going to start at the beginning to share their ideas with you, designed in succession. And then please save your questions, get them ready, and we're going to put up a little Mentee sign for you to put your questions to us on your phone electronically, and then we'll go through some of those for the second half an hour. So our speakers in order today are Professor Joeri Rogelj, who's the Director of Research at the Grantham Institute and a Professor of Climate Science, is that right? And Policy at the Center for Environmental Policy. And then he's going to be followed by Dr. Greg de Temmerman, who is the Deputy CEO of Quadrature Climate Foundation and also the head of science there. And then we'll be followed by Larissa Kunstel-Tabet, who's the head of the Climate Solutions Catalyst, which she will tell you all about when she talks. So without further ado, I'm going to hand over to Joeri.
Yeah, thank you very much. Really nice to see so many of you here. Great to see these conversations starting to happen at Imperial around climate change. And already a big thank you to the entire team that pulled together this event. I want to start my talk on current trends and urgency of action with this image. You probably have seen similar images in the recent news. Of course, this is an image of Los Angeles, the wildfires in Los Angeles, currently estimated to have caused $250 billion in damages. I took this image because it's a nice example of a climate extreme. It's also a very recent example. But I don't have to go back much further last year to give you examples of heat extremes and heat waves in India, drought in the Amazon, extreme precipitation and flooding in Europe. 2024, last year, was a year of extremes. Actually, an initiative here at Imperial, World Weather Attribution, identified over 200 instances where extreme events had such scale and such intensity that they warranted further investigation. 29 of those, they actually were able to investigate further, and particularly they looked at the fingerprint of human activities in those events. Every event, every red dot here is an event that has been made more severe or more likely because of human activities. I think you can see the pattern emerging. We live in a world where climate damages, extreme weather is happening because of our human activities. And this is, of course, not a surprise. We understand that risks increase with every increment of global warming. That is illustrated with this iconic figure of the Intergovernmental Panel on Climate Change. It's also referred to as the burning embers. It shows for 5 dimensions from unique and threatened ecosystems such as coral reefs or mountain ecosystems, over extreme weathers, global aggregate impacts, and large singular events such as tipping points, how the risk of adverse consequences increases and is assessed at different levels of warming. You can see this is the assessment that fed into the discussions of the Paris Agreement in 2014 and 2015. You can see that there is this clear increase in risks between 1 and 2 degrees of global warming. You could also see that at 1.5, we kind of avoid the strongest risks, particularly when we look at the global aggregate impacts and the large singular events. And that is the reason why the Paris Agreement set a global target of limiting warming well below 2 degrees while pursuing to limit it to 1.5. Looking further now, this was the information we had in 2014. The IPCC redid this exercise and published it in 2022. Is the same kind of exercise, the same risk assessment, but now with new information, new evidence, better science. And what you can see is a clear trend. The more we learn, the worse it looks. For each of those dimensions, be it the coral reefs or wetlands, the distribution of impacts or how poor populations are disproportionately being or how their development is being undermined by their struggle against climate impacts, or even the tipping points that were initially considered to be not really detectable at 1 degree of warming. Now we see a higher risk assessment and a higher chance of adverse consequences at lower levels of warming. So where does this leave us today? Last year was the hottest year on record. It was estimated that it was 1.6 degrees warmer than pre-industrial level, a level or a temperature that is driven by an underlying global warming trend that currently stands somewhere between 1.3 and 1.4 degrees. The question is, the goals of the Paris Agreement to limit warming well below 2 degrees and pursued to limit it to 1.5. How does the world stand on that? Actually, that is a question that we ask ourselves as part of the UNEP Emissions Gap Report, the UN Environment Programme's Emissions Gap Report, on an annual basis, and we have been asking us that question since 2010. Now, the assessment is that we are not doing very well. Actually, there is a huge discrepancy between the emissions by 2030 that current pledges of countries deliver and the emission reductions that are needed to limit warming to 1.5 or 2 degrees. There is not only a gap between that ambition of pledges and what is needed, but also a gap between the implementation of those promises, a gap between the policies that are being implemented and the actions that have been promised. What does this mean now for global warming? This is the assessment of last year's report, so the most recent report of the UN Environment Programme on this issue. And it shows how if we follow current policies, so that is the policies that are currently being implemented and that are on the books, which you see here at the top there, we end up with a central estimate of global warming by the end of the century of around 3 degrees. We have a 2 in 3 chance that we limit warming below 3.1, but there's still a 1 in 10 chance that warming exceeds 3.6 degrees. Also, at the end of the century, warming hasn't stopped, but is still increasing at several tenths of a degree per decade. So that is if we follow what countries are currently implementing. Trump was not in office yet at that stage, at the moment this report was written. If we now look at what countries have promised in the near term, and for those that follow the climate negotiations, these are the NDCs, the nationally determined contributions, the pledges of countries under the Paris Agreement. And if these are implemented, we roughly cut half a degree of these global warming projections. By the end of the century, we still end up with roughly 2.5 degrees of global warming. Again, warming hasn't stopped then, but continues in the decades that thereafter. Our final, most optimistic and most generous case is one where all the near-term promises and pledges of governments are achieved, and also their long-term targets are achieved. The UK, the EU, until recently the US, have long-term net zero targets. The intention to reduce all the emissions of their entire economy to zero. If these targets are achieved, we see a slightly rosier picture. Our central estimates end up with a maximum of 1.7 degrees over the course of this century, and we have a roughly 2 in 3 chance that warming is limited to 2 degrees. The challenge here is, of course, that currently no country is on track to meet its long-term net zero target. not the UK, not the EU, and not any other country that has that covers a significant share of global emissions. Where does this leave us? We've seen an enormous amount of global warming already. We see risks and impacts happening at lower levels of warming. Our risk assessment is strongly updated. So that means we are already living in a world that is not safe anymore. However, we should not give up. There is still an important difference to be made, and the choices we make today still determine to a very large degree how children that are born today will experience, or the impacts children born today will experience. It determines that it's the difference between seeing a world rise to 3 degrees and more by the end of the century and by the end of their lifetimes, towards a world where we manage to limit warming somewhere between 1.5 and 2 degrees, and maybe even can start to hope to reverse it by the end of the century. And on this note, I think it is clear that we have a very long way ahead, and I think that is the entire segue to our next speaker, Greg.
Thanks. So I'm not going to be making you more optimistic, actually. Does it work? Because what I want to talk about is something we don't talk enough about, which is how complicated this is going to be to get to a net zero place. Very well, it doesn't work. So when we talk about the energy system, 75% of the emissions actually come from the energy system. I'm going to focus on that. So getting to net zero, that doesn't work, right? Oh, yep. Getting to net zero is actually changing our whole energy system, which is powering of our lives, so everything we depend on. It's not going to be easy. This is a system which has been built around the last 200 years, probably, made better and better, using more and more fuel, becoming more efficient. So we have to change everything more or less within the next 25 years if you are serious. And it's important to realize that this will entail a lot of compromises and trade-offs, and that's what I want to talk about. Now, because there are so many great scientists here, I decided to take a step up and take you through an analogy about how it's actually going to look like. One thing I like to do during my spare time is ultra running, so run under very long distances across mountain. And actually, this is quite similar to what we'll have to do in terms of climate change. When you start a race, you know when you want to go, start point, finish point. The shortest distance between 2 points is always a straight line, right? I mean, we are in a new university, everybody knows that. Now, the reality of the terrain is that you have to start going around obstacles and so on, right? So your path is already longer than what you think when you just look between 2 points. In reality, most of those races are actually in the mountains, so now you have to start going up and down, up and down, up and down. So it's making your trip much longer for a certain distance. It's also making it more complicated, more technical. Now you're in the mountain, the conditions can change pretty quickly. You have to carry a backpack with you because you're going to run for the next 30 hours. And you have to make choices, what kind of shoes you're taking, how big your bag should be, how much food you are taking with you. And none of that is the perfect science. There is no perfect solution. You're trying to make a best guess estimate on the conditions you think you are going to face. If it turns out that you chose some very lightweight gear and then it's starting to snow, which happens even in August in mountain, then the only thing you can do is try to find something to cover yourself and just keep going because you're in the middle of the mountain alone. Now, the energy transition is exactly the same thing. You just have to make do with all the compromises and all the trade-offs you can find on your way. Just remember why it's so difficult. The scale of the energy system. 15 billion tons of fossil fuels, coal, gas, and oil that we are burning every year. Just in terms of, it's a big number hard to represent. Just in terms of volume, coal, 9 billion tons of coal used last year. This is the volume equivalent of a Great Pyramid of Gizeh in Egypt that we burn every 5 hours, right? Think of the amount of stuff we are actually digging out of the ground every year. This has to go down to 0 in the next 25 years, which is quite a big challenge. But we know what to do. We know we have to stop doing that. We have plenty of scenarios telling us how we are actually going to get there. Still, it is going to be quite difficult. So there are many ways we can start approaching the system. I think one of the best examples of how difficult and how much challenges we have to face is to look at the transport system. The transport system globally, road transport, 12% of global emission. We burn a whole lot of oil just to move people and stuff around. We know that electrifying road transport is actually the way to go, right? Electric cars, electric trucks also are the way to actually decrease emissions. So in principle, it's quite easy. We have technologies now, batteries are getting better and better, cars are getting more or less on par, electric cars and internal combustion engine cars are more or less similar. So we have a solution. So the first order solution will be you take all your cars, 1.4 billion cars right now on the road, you change them all for electric cars, right? 1-to-1. Seems quite easy. But if you look now at what a city looks like in many places, that's Paris at rush hour, this is full of cars. This is not really nice to live in. It's pretty hard if you want to be a pedestrian or a cyclist. Paris is getting better, was a few years ago, but still, in many places, it's hard to be a cyclist. If everybody was using cars like we do, or like the Americans do, where they tend to have 2 cars per household, you will need much more than 2 billion cars. So that starts to be an extremely high challenge. And now you have to start asking yourself, is that something we want? So yes, electric cars are the future of cars, but are cars the future of mobility? Now, okay, so you know what you can do? You can transform a city and develop public transport, metros, trains, trams, whatever you can think of. But that's hard. These are huge infrastructure projects that you have to start carrying. I mean, opening a tramway, which is the new thing that France is doing quite a lot, takes 15 years in a middle average city because you have to go through buildings, you have to get things down. It's quite hard because this infrastructure is not meant for that. So the interesting paradox here is that the best way to decrease emission for the transport system in the short term, electrify everything, might not actually be the best way to go on the long term. So how do you put the cursor there? Now, okay, you could say, then cars it is. Let's use electric cars. What kind of cars are we talking about? Go around the city, especially in the US, and what you will see are huge, big metallic monsters which weigh more than 2 tons. This is what we call cars. They are 4 wheels. Cars are getting bigger and bigger. Takes a very iconic car, the Volkswagen Golf. Used to be about 700 kilos in 1974 when it was first released. The latest version right now is 1.5 tons. And it still does the same thing, takes you from one point to another. Think about bigger cars, like one of the most famous cars in the US is the Ford F-150 pickup. The oil version, the petrol version is about 2 tons. The electric version is 2.7 tons. Do you know how much an average human weighs? 70 kilos. So 72 kilos of human in 2.7 tons of car. Is that really efficient? The problem with that is the more cars you need, the more electric cars you need, the more metals you need. Lithium, cobalt, copper, all those things to actually build everything. So now you have to start facing another thing, which is to electrify your system, you have to start mining more metals at least. So to decrease emissions globally, you have to start creating more impact locally because let's be frank, mining can be improved quite a lot, but it is still digging something out of the ground, which is very low concentration. Typically, copper is like 1% grade in tons, which means 1 ton of rock you are getting out, you get like 10 kilos of copper. So it's a lot of things you have to move, a lot of externalities. It affects local communities. It's not the best thing to do. So how do you place the trade-off there? And the more cars you need, the more extraction you need. And I'm not saying you're going to mine your way out of that. The question is, can you start playing on the demand and being a bit more rational on the car side? So yet another thing you have to start thinking about. Now, interestingly enough, when you talk about mining, remember those 15 billion tons of oil, gas, and coal you were extracting every year. Turns out that once you electrify, the total demand in mining is actually going to decrease. But it's a very difficult thing to communicate to the public because it's still mine that you have to open. So what I'm trying to say here is we will have to face all those things heads on, and we don't talk about that. We look at scenarios which are nice curves, an S-curve in one sense, in another sense. It's all smooth on papers. But we know it's actually much more difficult than that. Trump got in office 2 days ago. We know it's going to be a wreck for the next 4 years in the US. Political situation is changing, the economy is changing, and all of that we have to start planning for. When I start and I go on a race, I don't go there and say, oh, 100 kilometers to go, and I run, 95 kilometers to go. No, you start going to the next aid station, typically a few hours later. You go there, you reassess, you get some fuel, And then you get to the next stage, right? And you know where you want to go on the long run. You know where the finish line is, but you don't go in one go. You try and do and adapt your situation. We'll have to do exactly the same with the energy transition. We'll have to try and make effort on the short term, keep in mind what the long-term objective is, and adapt on the go and face all the difficult situations we have to face. Doesn't mean it's impossible, just means that it would be perhaps better to try and talk about those things, because backlash is one of the things we are facing, because when you say everybody's going to be winning out of a green transition, well, globally perhaps, and I don't even know, but locally some people are going to lose their job. Think about the UK, right, where you're extracting gas and oil right now. People won't have a job there because you might put your renewable infrastructure somewhere else. If we don't start discussing about that, then some people are going to be really upset, and those people vote also. So all those things have to be considered, and that's going to be messy, and we have to realize it. And I think we are right in the messy period now, and we have to make everything we can to make it a bit smoother. Thank you.
Hello, everyone. I'm going to try and juggle 3 things in 2 hands, so bear with me. Good evening. Thank you so much for those fantastic and inspirational, slightly nerve-wracking talks. I'm here to present a potential beacon of hope or avenue for some positive impact with the Climate Solutions Catalyst, which is a new program. But I wanted to start by just telling you about my journey towards working in climate solutions, which started during a trip to Tuvalu, a really fantastic South Pacific island group, where I witnessed firsthand the continuing and devastating effects of rising sea levels. So during high tide, you see the seawater come through the main roads, and this cemented my path towards taking action for our climate. And this evening, I'm delighted to discuss the Climate Solutions Catalyst, which is a groundbreaking program designed to accelerate climate innovation and support untapped academic research. Our goal is to explore how we can collectively contribute to tackling climate change through innovative deep tech solutions. So, Joeri has outlined the current trends and the urgency for us to take action, why it's so important. And Greg has highlighted that we know where to go to address the climate crisis, and that it's messy and the steps that we need to take. We want to get there as quickly as possible, and thank you for the race analogy. I've got a different race here. In this race, a range of solutions is required, aiming towards net zero. And they already exist and are invested in. But the Climate Solutions Catalyst is looking to add more runners to this race. And that's great news, because there can be more than one winner here to get to net zero. The Climate Solutions Catalyst is a 2-year trial program aimed at unlocking the potential of academic research to accelerate climate innovation. By identifying and supporting neglected climate solutions from the UK research community, we aim to identify a greater variety of innovations which we can fast track to make a significant impact in our fight against climate change. We are testing the assumption that there are still solutions to be found. And our approach is based on 3 pillars: on finding the research, on supporting the researchers, and in building and supporting the network. We're taking an iterative and startup approach to these. So to identify these neglected solutions, our team is mapping out the topic and challenge spaces within deep tech that are potentially neglected and searching within these landscapes. We're going to reach out to the networks and connections that we have already in place to identify research and researchers and create panels of experts within these different topic spaces. And further to this, we're going to be using machine learning to enhance our ability to read through the corpus of research, drawing references and connections and insights between various data sets to help us identify research with potential. So our initial experiment, there's a QR code here, so you can read our first steps towards this. And it was to start with the basics, see whether a chat tool could identify potential papers to the same level as human assessors. And funnily enough, yes, It can. You may have seen our poster in the main foyer, and after our panel discussion, please do come and talk to us in the main entrance. But our next steps are then to start layering other data sets and to use additional machine learning approaches to filter and identify papers that might otherwise be overlooked. And while we appreciate the speed with which this tool can supercharge us, we must remember to keep humans in the loop. And this is where those industry experts and research experts come in to confirm which of the papers we identify have the most significant impact. Once identified, these research projects are at the beginning of a well-established pipeline. I'm going to skip forward a couple of slides. Here we go. A well-established pipeline. Our role is to try and reduce any bottlenecks to take the research forward, and we have some small amounts of de-risking funding to do this. So once we can de-risk and find out from this research, I'm going to put this down, sorry. Once we can de-risk the research that we find, whether that's building a team, whether that is furthering technology development, we want to work within the existing innovation pathways, frameworks, to make sure that it can progress into the real world. And an example of this is the Undaunted model that we already have, where the climate solutions catalyst can sit at the very beginning of an innovation pipeline to identify research. We can then plug into existing programs that enable it to accelerate as quickly as possible. So for example, we have the Climate Launchpad, where people can quickly upskill and test their ideas. We have the Greenhouse, which is an accelerator program. And that's within Undaunted and the Grantham Institute, but these pipelines and frameworks exist in other universities. So you can find them within the Manchester Innovation Factory or within Bristol Set Squared. They exist, and if we can bring those together, along with industry partnerships, we can really activate the whole network. In addition, Undaunted has recently announced a new Climate Scaling Collaborative, which is a community of 5 different universities activating the whole UK landscape network in climate innovation, and we're very excited about this. And if the Climate Solutions Catalyst can then have its research work through those pathways, we believe that we can get to this finishing line a lot sooner. But the solutions don't only take place in the UK. And we have the Global Climate Innovation Network, which was recently announced, which then brings in global hubs to accelerate change. So the solutions catalyst, as with any experiment, we expect that it won't be smooth sailing. And Greg has mentioned this. You know, you have to take one step to the next step. We're taking an iterative and startup approach to these various pillars. And our search will run within 2 rounds, each with a specific topic selected. The first will be catalysis. So the Climate Solutions Catalyst looking at catalysis and green science innovation, because it has many different applications and industries where we see that it can either mitigate or remove carbon from our atmosphere. We expect that there will be much learning to be had, much as I expect that I have much learning to have as well in presenting. But we expect that we can build this framework to identify research, and that together, building this community, we can increase the number of ideas that can progress to net zero. So, in conclusion, the Climate Solutions Catalyst is an important initiative that leverages academic research to drive climate innovation. And I encourage everyone to get involved. If we can identify those that are overlooked, if we can find researchers that are not being celebrated by using our own networks and by using machine learning, then we can get to winning the race faster. Thank you.
Okay, thanks, Larissa, Greg, Joeri. So now's the moment to think about all the questions that you want to ask all of those people, or the discussion you'd like to have now. In a moment, we're going to have a QR code on the screen. Will it happen? Here we go. So if you follow that code on your phone, you'll get to the Menti site where you can type in your questions. And if I can invite all the speakers back up the stage. Just going to give you all a moment to think of your questions. Okay, oh, I have one. Here's one. Okay, great. Type your questions in. I'll start by getting you all speaking to each other. You've all heard from each other. We got Larissa to finish a bit on the hope and looking for solutions. I'm gonna ask you each to say what's keeping you hopeful at the moment, or what's the thing that's keeping you moving at the moment, driving you, and while we get some questions from the audience. Might start with you, Larissa.
Oh,
it should just
okay, hello. I think what I've been finding most exciting working within the Climate Solutions Catalyst is that we're a very diverse team. We are scientists and designers and innovators, but then extrapolating that, how do we find what is neglected by utilising the skill sets of the team, the networks of the team and the wider team? I think that we have the potential to unearth ideas which can be revolutionary and dramatic in our search for climate change innovation, that there are researchers within universities that may not have those innovation pipelines that I was talking about, that we can really activate and see how we can take it forward.
Perfect. Joeri?
Yeah, what keeps you going? I think it's both the necessity and the opportunity. The necessity of also the basic physical understanding, the human suffering and the harm that climate change is causing, the fact that it is inescapable to do something about it, so you can't give up. That is kind of a strong driver, but a more of a negative driver. A positive driver is the opportunity. The Climate Solution Catalyst is great at looking ahead and kind of starting those innovations that can make a big difference in the future. We have so many solutions we can implement today, and the opportunity there lies not just in avoiding and limiting climate change, but also in improving lives for people with better homes, healthier lives, better diets, and so on.
Perfect. So plenty of reason to come to work. It's good. Greg?
Well, as much as we can be negative, there are also a few positives. Things are moving, not fast enough, unfortunately, but there are many things which are happening which I don't think anybody would have predicted 10, 15 years ago. I mean, talking under your control, obviously, but we have everything we need to decrease emission by a factor of 2 in the next 10 years. We know what to do: electric cars, renewables, batteries. We know it's not a technical problem, which doesn't make it easier to solve, but we have all those solutions, and we have them because there has been an incredible amount of progress in the last 10, 15, 20 years on cost of renewables, batteries. We have PV, so photovoltaics right now is the fastest deploying technology in the energy history. We have never deployed anything faster than that. Batteries are actually going faster now. Of course, we are comparing slightly different things. So there are things which are happening. The question is, how long can we keep on doing like that while you are facing some headwinds? But it's becoming less and less a technical problem and more a political and kind of engagement problem, which is great because at least we have the solutions we need. Not everything, still some things need to be done, and research and innovation is important. But in the big picture of that, we know what to do. So it's kind of, how do we now push on that?
Okay, perfect. Well, you anticipated perhaps some of the questions. No, I mean, you weren't to know that. So it shows everyone on the same page. But I'm going to take us a step back because there's some questions here about the difference between approaching this from a technological innovation perspective and the other things we need to be doing. But to take a step back, someone correctly pointed out that the title of this talk is Changing Trends in Climate Research, and we haven't talked about what are the changing trends in climate research. So that was sharp observation. So let's just follow through on that. I'm going to start with Joeri there, since you're professor of climate science, so you can tell us what we're seeing on the research. But then also maybe I'd like to hear from you, Greg, since you're now starting to think about, as from a philanthropic perspective, thinking about engaging with research, and then I'll come over to you afterwards because you've got a lens in there on some of the research as well.
Yeah, I think it's a good question, yes, and I also want to say mea culpa. I'm not talking about the trends in climate research. But it is clear that climate research over the past decades has almost over more than a century has looked at really understanding the problem, has really, but by now has established our solid confidence in our understanding in the physics and the chemistry of climate change. Now climate research is more and more starting to look at the solutions, and that is not just at the technologies, that is also really at whether, for example, anything that we are considering, like afforestation or any of the natural systems, whether they will be resilient in a future that we are now already, that we have been committed to, with our historical warming. We are also more and more looking into making research and knowledge more readily available. We are here, in the center of London, extremely privileged, both in terms of the people we can interact with, the connections we have, and the resources we have available. For many locations and geographies around the world where that struggle to an even larger degree with climate challenges, be they adaptation or mitigation, do not have the access to the knowledge, to the basic knowledge. And a lot of research, including connections with machine learning, looks now at also basically democratizing access to that knowledge.
Okay, so that's great insights. There changes a little bit in the topics being addressed, but also in how we're doing research and who we're connecting to. And it's interesting, actually, if you speak to some of our researchers here, the way in which they engage people doing health research with the people who would previously have been only subjects of their research and are now active participants in the research also builds a very different relationship. And I think we'll see some of that coming, hopefully, with climate as well. Yeah. Greg?
One thing we're working a lot on at the foundation, and we are basically, our work is to support other people to do the work, which is great, is actually how do you bridge the gap between science and decision making? Science is there, I mean, can always do more and improve that. In terms of solutions, scenarios, we have a lot of things, but still things don't percolate to the decision makers, or they choose to ignore it, which is also another thing. So we are doing a lot of work in what kind of tools can we use, create, develop, so that the core sciences can be made in a way where a decision maker understands what you're talking about, which is really one thing, but can also understand the consequences of not doing something. So is there a way that we take those scenarios and we make sure that people understand that if you don't make an investment decision now, everything is starting to shift, right? And it's something which is quite interesting. And then that requires to also start speaking a different language. I'm a scientist, I used to be. So we are used to talk to other scientists. Now you talk to people who have to make decisions with very different stakeholders. And I think that's another one which we should never forget, is why is action not happening? It's because there are many people who have an interest in the system not changing. And as a foundation, that's something we are doing quite a lot of work and support on, is how do you fight all the lobbies which are very active there to try and avoid the science to be made for a long time. Now I think they gave up on that. There was an interesting report, I think last year, looking at new climate denial, where it looks like people are less and less attacking climate science now, still some, one of them president, but it's mainly now attacking more and more the solutions. So just go on YouTube, and I did it again yesterday, go on YouTube and type electric car, electric vehicle, and look at the numbers of the first 10 videos you see. 5 of them are actually saying electric vehicles are not a solution, right? So where is that coming from? It's not just automatic, right? There is something behind that. And that's, I think, where it's not purely science, but how do you also fight? And you can use science to try and fight those also algorithms.
Right, okay, so yeah, that's really helpful insight. I'm gonna morph the question a bit for you, so sorry, that's gonna be an unhelpful surprise. Which is, if we step over a bit more to the innovation side, what is it that we can be doing better, either through scientific research or through our other activities, to help start to bridge either, the kind of the technology or the innovation that we have, and take it through to actually being implemented?
Yeah, I think that there are changes and trends around the types of technology that people are exploring. So whereas mitigation is quite saturated and very, very well explored, we're now having to start to look at adaptation and resilience and the new innovations that have to take place within that space. If we've got continuing wildfires that keep on coming up earlier and for longer every year, hurricanes and flooding, we have to start changing our approach. And by addressing adaptation and resilience, we can also start looking at mitigation. We can actually double down on how these can come together and complement each other as well. I think also to the point that you made, Alyssa, like bringing more voices into the discussion and implementation. We're finding this with CDR innovations, that if you can engage with the communities where these new ideas are going to be implemented and actually get buy-in from the communities to work with it, to apply for new jobs within these spaces, that you can actually accelerate further, because you don't have people saying, you know, these electric vehicles are a sham, because they can actually see and experience and see the benefits of these different solutions.
Okay, great, a lot there. So we've got a few very specific questions here. So this is the rapid fire round of this. I've chosen one for each of you. So I'm going to ask you about what you think about this topic, nuclear.
Oh, wow. A very famous, quite famous, or not so famous, I don't know. Energy historian calls it a successful failure, and I think that's the perfect definition of nuclear. That works, that does great, that produces huge amount of clean electricity, but we have never managed to scale it. I mean, we did it for 30 years in the 70s, and then since then, the number of reactors which are being built is hardly compensating the number of being closed. And in the West, at least, we can't build them anymore. So I think it's interesting, but it might just... And the other thing which is interesting is that there is a race. This is like the time for nuclear. If people can't get their head around and engineers can't fix how to build those things, which is something we used to be able to do, the race is continuing without nuclear, right? Keeping that same analogy. Other things are moving along. So there is a risk that nuclear becomes totally obsolete because some other things are better. I think the one thing I want to say though is closing a well-working nuclear reactor is probably the most stupid thing you can do, because this is providing clean electricity. So if your nuclear reactor is safe, well, you might as well run it, and some countries can be pointed out.
Great, all right. So your rapid fire question, Joeri, subnational transitions and policies.
Okay, two contexts here. I think very important subnational transitions already from a context just of the just transition. National policy, national targets are implemented locally. So it's extremely important to bring communities together in this transition. And these can be communities that have historically been mining communities, oil and gas communities, or communities that will now be impacted by kind of deployment of new renewable energies, and also need to see the benefits for their lives from it. Of course, the other important context for subnational action is now at the other side of the pond in the US, where at the federal level you can see kind of a shutdown of ambition. Last time this happened, it actually catalyzed a groundswell of state action with even pavilions at the climate summit, so the COPs, of non-state actors, or in this case, these are cities or the US states saying, we are still in, we will continue. So I think the fact that climate action and the solutions to lowering emissions actually bring benefits to the economy, to people's lives, to people's quality of life is something to keep in mind, and also something to keep in mind when considering how easy it would be or how hard it would be to really halt it entirely.
Okay, perfect. So place for subnational policies and really connecting to people also there. Great. All right, so Larissa, your rapid fire question. Directly related to the catalyst you showed us, can you share with anyone anything interesting that you've unearthed? Is there a neglected opportunity that you're willing to share with people? I know it's early days.
It is very early days. You put me on the spot here. I think we've now picked our topic space, so we're a few months into our program. What we've unearthed, which I'm quite excited about, is that we can use machine learning, and we know this, like there are many different people using machine learning in different ways, but we can really use it to extract information in novel ways. We can use it to speed up our processes. So we ran this experiment of reading through 100 random papers, and can a machine learning search tool, if given the same questions as a human assessor, identify five papers which we know to be successes. So we seeded those 100 papers with 5 potentially successful spin-out papers, and can the humans and could the machine learning search tool identify those 5 papers? And in both cases, it was successful. Humans, excellent, and the machine tool also did the same. And what it did do was find a 6th paper, which the humans didn't, that where a researcher, it wasn't that research specifically spun out, but the researcher who wrote the paper then went on to spin out some later research. So already we can see the potential there. Within our topic space of catalysis, what we've started to do is reach out to various academics within that space and ask them these sorts of questions. Is there research that you think's neglected? And what would you want to do with it? And we have 2 or 3 people already going like, this is on my bench and it's really exciting. I wish I could get some funding for it. I wish I could take it forward. And although that's not our mission within the Climate Solutions Catalyst, we want to be going to people and saying, hey, we found this. I can already say, please talk to these people, go here, go there. Already start engaging with the network to take that forward if you're truly excited about it. So that's what's sort of really giving me energy.
Okay, brilliant. Great, thanks. So I'm going to continue on this theme of changing trends in climate research. And as you said before, Joeri, all of us on the stage are privileged to be able to work on these issues every day, and we get to have quite a bit of insight into what can really make a difference and what excites us. So whilst this is all of our professional activities, I want you to put a lens of that on your personal interests on top of that. What are the things that you've come across that are these trends, things that you think can really make a difference in climate, that actually you're most personally interested in? The thing that you're like, I'm going to stay 5 minutes longer in the office, I'm going to read about this. The thing that, grabs you personally, Joeri. You find your job interesting, I'm sure, so this should...
I do. And being a nerd, of course, I like to dig in any paper. But I think the really interesting part is there where you see science and evidence connect to society. Anywhere where kind of the very well-founded insights actually influence decisions. And this can be in many areas. This can be somewhere where you could really inform a decision that now is well evidence-based and is going forward in a government department. This can be by informing a judge to make in a litigation case. This can be by helping NGO really understand how their societal concern can be translated in a position that they are then advocating for, but which is evidence-based. I think these are the moments where you really, you take the extra 5 minutes, 5, 10, and then of course you have budgeted the time wrong, and then it's 3 days. But that's the moment.
Okay, perfect. And you're seeing some of those, is your point, right?
Yes.
You're seeing some of those. Okay, great, perfect. Greg.
Oh, I'm also a nerd, so that's not going to help. I'm just going to say what I'm reading right now. I'm reading a lot on economics right now because macroeconomic is an interesting thing, and all of the macroeconomic model, when you apply them to climate, actually don't help you so much because they tend to minimize the amount of damage you think there will be. And then there's a lot of all philosophical discussion about then it only measures GDP and that's not anything. And there are some very interesting approach which are using what we call agent-based model. How do you try to get humans into a model and try to get better modeling? There's a group in Oxford, I'm sure there are some people here doing that also. It's quite fascinating how they are actually approaching the system. And why I'm interested in not so much into that modeling is how can we get those models in front of decision makers which right now use the same kind of macroeconomic model which always assume that the future is less important than the present, which we call discount rate, which is always making climate action less interesting. I mean, things are evolved, so I'm kind of simplifying. But in reality, things are going to be much more difficult. So how can we get policymakers to understand that it is actually in their interest to invest in climate change? It's going to be cheaper to invest in, not in climate change, sorry, in stopping climate change, because we are pretty good at doing the opposite. So it is in everybody's interest, there will be benefits and so on. So I think, yeah, I'm quite excited by that those days.
Okay, great. And I think it's also not just about policymakers. I mean, the microeconomic perspective also tells us about individuals. Yeah. And I'm building that in because someone asked that question also. How do we get it to work for individuals as well? Great. What are you finding personally interesting?
I think there are a couple of things that I'm finding personally interesting. One is this idea of combinatorial innovation. So how can we take two ideas from wholly different domains and bring them together and support a climate solution in that way, or create a climate solution in that way? So where you're applying a technology from one field in a completely new field and seeing the benefits of that. And I think we're hoping that down the line our search tool will be able to do that. So I'm very interested in that space. But then looking at the systemic world of implementing that innovation, so whatever you're putting into a new space will have knock-on effects to the world that it will sit in, and whether they are benefits or disbenefits, how can we predict what they may be so that we can actually design our innovation in a better way so that it doesn't have as many ripples and that the effects are more beneficial than not beneficial.
Okay, perfect, great. Well, I love the way you all kind of lit up as soon as you started talking about the thing you're really passionate about. You can see, like, within the passion is a passion, so thank you for sharing that. Okay, well, we've got nearly just under 4 minutes left, so obviously now I'm going to ask the question about politics because we have to ask the question today. When you spoke about running the race, Greg, you know, there are lots of hurdles along the way, and I completely agree with you. There is always context. So if we consider the context that we're in now, there is a little bit of a backlash against talking about net zero, thinking about climate, and depending where you are in the world, these things look different. What do you think in terms of, you know, we're going to continue to need political and societal innovation. You spoke about economic innovation. We need to think about how we communicate and share information. So what do you think we should or could be doing there? And we only have 3 minutes, so don't worry. This is not the whole rest of your week. Just a snippet, each of you. Greg.
I think one key is to find a way to make climate a non-partisan issue. It has become something more from the left to look at, and the right doesn't like it. And I think it's damaging, and we know we are, I mean, you say a few ripples. I think we are having a huge headwind right now, and it's going to be like that for a couple of years. Look at the elections coming in Germany. I mean, this is the US, but many countries are actually backlashing there. So I think there is a real question about how do we find a way to make sure that all parties understand that there is a reason to act on climate, and that's not going to be the same driver. Some of them will be interested in the economics aspects, some of them on the social aspects, but I think that's the only way we can get out of that. Or assuming that the market will do it, but the fact that economic actors will see an advantage in going for clean technology and will invest in that independently of what happens. But the problem with that is most of the climate solutions we need at the beginning are more expensive and a bit less efficient than what you're trying to replace. So the market by itself can't do it. So you have to have some forces acting on it. So yeah, I think finding a way to talk about climate which is not like conservative and Democrats on one side. I mean, so I don't know, I guess.
Okay, perfect. Larissa.
I'm dying to jump in here to respond to what you're saying, Greg, because I think that is so important that if we can take climate change and the scariness of it and how huge it is out of the equation, especially for local people that are probably the ones creating the YouTube videos and writing on social media in quite a negative light, that if we can take that out of it and start flipping the perspective where it's climate solutions and taking steps towards the benefit of the climate is a global good. You can take the word climate out of it, but if you can implement something which can be perceived as good for society, good for your community, good for your family, isn't that something that we should strive to, that we should want to do? And so how do we start empowering people to think in that way? Because we're facing something that is ultimately quite scary, and we want to protect our families and our way of life and all of this. So, yeah.
Great, perfect. And Joeri?
Yeah, much has been said. I think a key aspect here is that we have to be able to make action on climate change both the responsible and the sensible thing to do, because it is. It is the responsible thing to do because the climate impacts and the harm that we will be causing by not acting are honestly unimaginable. I don't think anyone really can imagine what a 3-degree world is, which we are perfectly still on track for by the end of the century, looks like. And it's the sensible thing to do. It's the sensible thing to do from a global economic point of view, but it's also the sensible thing to do from a personal life, quality of life point of view. And so providing these kind of positive stories, both of responsibility and sensibility makes, for it to be sensible is, I think, can be empowering.
Okay, perfect. Well, thank you all for your insights. We could go on for ages, but I think it would be nice if we finished close to on time. So we're going to wrap it up now. Thank you all for your amazing questions. Some of you have not maybe had your questions answered, or you wanted insight into what technology to invest in, etc. What's the latest coming down the line? You can come up and speak to us afterwards. A few little housekeeping things. First of all, there are some canapes and drinks. And if you go through here where you came in, back to the main entrance of college, that's where you'll find them. Also, with great thanks to Polly, who put together this event, it would be really helpful for her if when you get that email, or is it on this QR code, there'll be a QR code to give her a bit of feedback. So if you can tell her how wonderful it was and how it could be even better, then that would be great. And I think, we've spoken quite a lot about the trends in research, and we sit very much at the research end of trying to impact and change these things. If this is areas that you're interested in making a difference, there's a role for everybody. And if you're struggling to find that, approach us and we'll try and point you in the right direction. If you are a researcher here or elsewhere, or involved in some of those early phases of innovation that we spoke about, then there's plenty of ways for you to get involved as well. So please reach out to the Institute, and we'd love to engage with you further. So thanks so much for your time.